Hey, what's up guys? So in this video we're expanding on the trigBoard project, which is a long-term IoT project based on the ESP8266. So in case you're not familiar, this is where we keep the Wi-Fi module in an ultra low power sub 1 microamp state and then wake up via some type of sensor, typically a normally closed door sensor, wake up, connect to the internet, and send a push notification to your mobile device. So that's the inspiration for the project, and I've expanded on it several times, but in this video I've added a camera. So now when the door opens or whatever, doorbell rings maybe, it will take a picture and you can view that picture on your phone from anywhere in the world. So very cool stuff. Let me show you what I've got going on over here. Alright, so here's what we got. And by the way, just before I give you a demo, I just wanted to quickly mention that everything you see here you can easily breadboard out with any other ESP8266 breakout board. So I'm just using my own stuff that I designed, and I did do a small batch on these boards, so check the description below if you're interested. So what we have here though is one of the trigBoards. We have an interface board and an off-the-shelf ArduCam. I think that's how you pronounce it. And this is the 2 megapixel ArduCam Mini. So that is interfaced up with the ESP8266. And now, by the way, it all runs off of a battery. And right now, it's sleeping, just sitting here, is pulling less than 1 microamp. And if we go, and let's say that we open the door. This is just a standard, normally closed style door switch. I'm going to open the door. You see the board woke up. It just took a picture. And then now it's going to upload that picture to a server and then post the link to where that picture is in a Slack channel. So you can see the LED there is flashing because it has to upload the picture to the server one small packet at a time. So it can take a little while, especially depending on the resolution of the picture you're taking. Now, going over to Slack, it's not the greatest picture in the world, but there we have it. So this is right here, the trigCam, and it's posting to a Slack channel. And I made a video on how to post things to Slack in a previous video. But you can really do anything you want with this picture. You can send it via text message. You can post it via pushbullet, so you get it instantly on your phone. Slack can also be configured to send push notifications to your phone as well. And I'm just loading up Slack now on my phone to show you what that looks like. And there we go. So I've got it up on my phone here. So if I'm traveling or whatever and I've got this camera monitoring several doors in my house, I can check and see who's there. The other thing that I will do eventually is have an always on trigBoard or always powered on trigBoard, so that when any of the doors in the house are opened, this board would then be triggered to take a picture. So I could have a couple of these set up that are wall powered, always listening for any activity from any of the other boards, and then start taking pictures so that you can kind of see what's going on. So that's the demo. Now we can get into the design of this whole thing. And I just want to quickly mention that what I'm doing here and how I was able to accomplish all of this was just a crazy long weekend project. So a lot of this was sort of hacked together. It does work. It works reliably. I've had this set up for a couple weeks now running. I also have one at our office door that takes a picture anytime somebody comes through the front door, and haven't had any issues yet. But when it posts the pictures to the server, it is not doing that in a secure way, so it is hackable. It's not doing anything with SSL or TLS or anything like that. So just keep that in mind, that this is a DIY type project. So let's go ahead and jump right into the design of it. Okay, we're just going to spend a little time here in the wiki. First place we're going to check out is the trigBoard. So this is the platform it's based off of, and in here we have all of the information for just the trigBoard, including here's that video on how to post to Slack, as well as the schematic. So I've got the schematic here, and I just want to show you a couple things here. So this camera interfaces to the ESP8266 over both a SPI and I2C interface. I have expansion over here on the board, and that is broken out, but you might notice that there is no chip select pin. And on the ArduCam, you need a chip select pin to control the SPI. So we've got the I2C, 2 pins for that, the SPI clock, MISO, MOSI. So what I had to do is actually tap into GPIO, GPIO 16, which is the external wake pin for this project, which is fine because we only need the external wake pin when it wakes up. As soon as it wakes up, we go and read this pin. That tells us if it was an external wake or a timer wake, because on a timer wake, we just go back to sleep, which, by the way, one of the cool things you can do with this is just every time it wakes up off of the timer wake, which is once an hour, take a picture and log it. I actually did that when with my 3D printer when I was printing like a crazy long 15-hour print. I set up this camera and once an hour took a picture and posted it to Slack. So I sort of had the sequence of how it printed. It was kind of cool. So anyway, so I had to use that external wake pin though as a chip select for the ArduCam. And I'm just gonna go back now to the camera board page. And this shows the connections for the camera interface board that I made. And basically all this does is solder up next to the trigBoard, which has this pin out, and then just reroutes all of those pins to meet up with the ArduCam's pin out so that it just plugs right in. You can airwire this, which I've done, and again, like I said, you can make all of this work on a breadboard. Just take whatever you see in this video, whatever you see is useful, just implement that into your project. So there you have all of the connections, and then I'm showing there on the back side the chip select pin. So for this, I had to actually attach a little wire over to the 4th pin down, which is GPIO 16. Also, just by the way, I've got the code up here, the Arduino code and the PHP code, because this does require you to have some external server somewhere to store these images. And I'm just using my website for this, and we'll get into that in a little bit. So basically we're storing all of the images there and then posting only the link to where those pictures are in Slack. Okay? So that's all there is to the hardware. Now we can jump into the code. Here is the code for this. And basically all of this was built off of the base firmware that I've already discussed. So if you jump over to the trigBoard wiki page and then just go down to base firmware, you'll see here the released code 1218, and I've got the video that walks through that code line by line. You might want to watch that first because in this video I'm only going to talk about the new code added in to support the camera. And you can see that right here. So this was all added in because the camera needs the I2C, SPI, and then of course we're going to use the ArduCam library to make life easy, and that's straight from the designer of this board, and you can download that library right here. And just focusing only on the new stuff for the camera, we're just going to kind of scroll down here. There's the chip select pin 16, which is also shared with external wake pin 16. We already discussed that a little bit, and we'll talk a little bit more about that as we work through this. There's the ArduCam OV2640, and that's the one I'm using, the ArduCam Mini 2 megapixel. So you might have to tweak this if you're going to use a different camera, but I'll have a link to where you can get the exact camera from this project, so all of this should just work. Scrolling down here, when the board is triggered, we start right at the setup. It checks the trigger right away to see if it was an external wake, and if it was, go ahead and take a picture. So now we have a new tab called Camera, and in here we have 2 new functions, take picture and scrolling down, upload picture right there. And in the take picture, the first thing we really do here is wait for the external wake pin to go back high. So obviously that pin gets yanked low when it's an external wake. So we got to wait for it to go back high. And it's funny, I think my comment is backwards here. So ignore that. But we're really waiting for it to snap back high. Let that pull up, snap it back up so that we can now use it for the camera interface. So as soon as that happens, because by the way, this is all part of the RC time constant with that whole trigger circuit. So I did a video on that too, but we've got a little bit of time after it triggers that pin would still be low. Okay, so now we can grab the CS pin, we can use it for the SPI interface. That's why we do the SPI.begin, wire.begin, and then we've got a couple while one loops in here which are kind of dangerous, but in here we initialize the camera and make sure everything boots up properly for the camera, and that's what this does. And this is all straight from one of the ArduCam examples. So this was all leveraged straight from there. So it first checks this here. So it looks like it's writing a test to a register and then reading it back and then making sure that it's good. And that will tell us that it's up and running and it's hooked up. Then we have another while one loop here, which is checking to make sure that we have the OV2640 over there at the ArduCam. So it's checking that, and if it's good, we're all good, and move on, break out of there. So then now we initialize the camera, we set the format for JPEG, initialize the camera, and then we have a few options for the resolution. And it seems like the best resolution I could get out of this camera is 800 by 600. We might be able to do 1024 768, but so far it seems like 800 by 600 works best. And just keep in mind that each one of these resolutions comes with a different size of the image. So you got to keep that in mind. Like if you want your image to be uploaded fast, then you might want to dial it down to 320 by 240. 800 by 600 is going to take a while to upload because I have to upload in small packets. Okay, then we have this little delay here, and that's something that I've been kind of tweaking with, trying to find the perfect time there. Right now it's set for 1100 milliseconds, but anyway, there's a few opportunities to tune things out in this code, and that's one of them. Okay, then we flush out the FIFO, clear the flags, and then this is when we actually take the picture. So it takes the picture and then just waits for we have another while loop here, and it just waits until it actually gets the final pictures done bit back. And then we're done. We've got the picture is taken. We don't yet have the data at the ESP8266. It's all the data is living in the camera, which is fine for us. We just want it to take the picture, hold on to the data, and we'll be right back. Okay, so now we have the picture taken. Then we go and read file, and that is in credentials here. And this basically just pulls out all of those configuration parameters from the SPI Flash file system. So, that's where we have the Wi-Fi credentials, the token for pushbullet, or the URL for Slack. And now I added one in for where you're going to keep the file. So let me give you a little demo of how you actually set this thing up out of the box, just real quick. Okay, so I just put the board in Wi-Fi reset mode. I held the wake pin down through the OTA mode until I saw the fast flash, and then now I can go and connect to it. So I'm going to do that now. Okay, so we're using the Wi-Fi manager for this, of course, same as the base code did, but I did add some things. So I'm going to click configure Wi-Fi. So once you get here, you're going to click on one of the SSIDs you want it to use, put in the password. Since we're using Slack for this, we're going to put the full Slack URL right there. Go back, watch the Slack video for that, and you can do that. You could also configure this for pushbullet if you want. That's totally fine. I'll show you where to change that in the code. Here's the name that you're giving, the unique name for this board, and then the message you want that board to send out, trigCam triggered. And then this is new. This is where you put the URL for where you want the files to go. And the only thing I'm going to mention, and by the way, I'm going to take this down when I'm done, but the only thing to keep in mind here is make sure that you have this slash at the very end. That's critical. So if you miss that, it's not going to work. And I've already got this folder set up, test for video, and that's where the PHP code is, and we'll talk about that in a little bit, but I just wanted to show you how that works. So I'm going to go ahead and put my Slack, oops, I missed the timeout. There's a 2-minute timeout that you have. So I'm going to put my credentials in and I'll be right back. So I just wanted to show you that real quick because it's pretty cool. Now you can just put that URL in the Wi-Fi manager and it basically just works once you load this code up. So if you have other things already in there though, that's what this line is actually checking for, so that if it does not have that file URL in there yet, it will actually format out the whole file system, which is fine, and then go to sleep. So you'll have to wake it up again. And because we're sharing that external wake pin with the camera, you're going to have to do something a little different to get it to reset its Wi-Fi settings and launch the into AP mode so that you can connect to it. Because right here, if you continue to hold that pin or hold the wake button down, you're going to get stuck here. So you actually have to just wait, hold it, press the button in, let it wake up, let go of the button, and then once you start seeing the LED turn off and then back on or whatever, because right here, hold on a sec, let me show you where it is. I actually turn the LED on after the picture is done taking. So after you see the LED flash, now you can press the wait and hold the wake button and it'll get you through into resetting the board and going into AP mode. And by the way, I've discussed this in previous videos too. So, well, not that part of sequencing, but at least how to get it into AP mode. So, and maybe I'll do another video on that too, in case that's confusing. So, all right, let me get back now to this part here. So once it finds those all of those keys here, the file URL, in addition to the other stuff we've already had in, it'll pull all that out. So now we can use those as variables in the system. And then what it does is after it's done reading the file, it goes to the Wi-Fi connection function, which is over here in provisioning. So if I go in, you'll see Wi-Fi connection right here. This is all the same as before, but now we have a couple other parameters that we're pulling in. So we have the file URL pulling in, and now we're using that here in the code as file URL, and that's what we use now to build it out, and that's how we connect and store our images on the server. Okay, and I won't get into too much of that, but when we scroll down, all the way down right here, and this is where it actually sends it out, we're doing the push to Slack. You could just change this, instead of pushing to Slack, just change it to push status, and then it would push it to pushbullet. So we have the two tabs, pushbullet and Slack. So I guess you could get it to work either way, but this whole example here is set up for Slack. And right in here, you'll see now we have a function upload picture, and this is really where all the magic takes place. So I'm going to go into camera and down here to upload picture, and this is where we actually upload the picture. Okay, so the first thing we got to do though is read it out. We've got to read out each byte out of the camera and send it up to the cloud. So the first thing we do is actually set up our file name. So we get the length read out, the total number of bytes in the buffer, print that out. Just a lot of this stuff was in there for debugging purposes. I've got some really nicely named variables in there, I and J. I'm not even sure if I actually use those anywhere, but they were left in. And right here is where we grab the timestamp. So this is some code I found somewhere that goes and grabs out the timestamp, and then we can use this time now here to actually build out our time. So right here we have the string time name, and then we add a little timestamp to it, and it gives it to you in a format that includes spaces. So first we trim it off, get some of the end characters and crap off of it, and then I loop through that string and replace all of the spaces with underscores, because we're going to pass this as part of the file name in the URL that we use to store the images. And in a URL you can't have spaces, so I replace those spaces with underscores, and then go ahead and tack on the file extension, which is JPEG. Print that out just so we know what we're doing there. And then we create the character array for it, because that's how I have all of my stuff set up, that I pass character arrays into it, so it just makes it a little bit easier. And we're going to store that whole thing in file name right here. So that's what we've got it stored as, is our file name. And that is actually stored as the, well, it's used as part of the URL file name. We're going to do an HTTP post for the data, but the actual file name will be part of the URL. And this will make sense sort of as we work through this. So this looks pretty familiar. I've done a few videos on this same exact sort of setup. We're going to do HTTP here, and we're going to have a target URL. So that is the URL that we just pulled in from the Wi-Fi manager. I'm going to convert that. It's a character array. We're going to convert it to a string, and then we're going to add from micro.php, and this is the PHP file. We're going to review that too. We're going to tack that on and then add on a variable data equals, and this is again part of the URL, data equal, and then we're going to add to that the time name, which is the file name that we were using. Okay, time name and file name are the same thing. Okay, so file name I had to use later on in the code, but time name can be used now since it is a string. Okay, so hopefully this is still making sense to you, but we've got the file name built out. We got this big URL, and it's got / from micro.php _ data equal, and then the file name would be out here with the timestamp .jpeg. Okay, so target URL, we've added that in. We're going to get set up here to read the data out, and we're going to read the data out in small packets and upload them one at a time. So now we can drive the chip select pin low, and we're just going to read out these bytes one at a time. So here you go, read out a byte, store it in temp. So, and then decrement the length as we read it out. And then right here you see while length minus minus. So it's going to just burn through this while loop until all of the bytes are depleted out of the buffer. And we keep track of 2 bytes as we read out, the last byte and the current byte. And the reason for that is because we're going to see a sequence of 2 bytes to indicate if we're at the start of a packet or at the end of the packet from the buffer. Okay, I shouldn't say packet. It's really the entire JPEG file out of the buffer, and we have those 2 start bytes and 2 end bytes. Okay, so that's why we read out 2 bytes and keep track of the last byte we read. Okay, so right here you'll see we're looking for the header. I'm just going to show you the full while loop here. So it's that whole thing right there. And right away when we go through this, our header's not going to be true, so I'm going to skip that. Okay, so if header is true, I was going to the wrong one. It's not going to be true when we first jump in here, but so we have this else if, and this is where we're looking for the current byte we read and the last byte we read. So it would be FFD8. That indicates the start of the file for the JPEG image coming out. So that's why before we even jumped into this loop, we first read out a byte. Okay, we read that out, stored it as temp last, and then we got another byte. So now we have 2 bytes, temp last and temp, and down here we can compare that. So we're looking for that. Otherwise, if we don't see that, then we're just going to keep burning through this until we're going to keep doing this right here until we find that sequence of FF then D8. And as soon as we do see that, it's going to set the header to true. And then I've got some debug information in here, and it's going to add that to the payload. And the payload is the actual string that we're going to tack on in the HTTP post, and that's going to be our full packet. So it's going to consist of bytes separated by commas. So right here, when we finally find the header, we know that we want to store both temp and temp last. So that's why we do the concat of the last and the temp, adding those commas in. And now we've got the start of the header, or start of the file. And next time we loop through this, the header is going to be true. So we can, right here, just keep going through, adding on, and if it is less than, if the payload length is less than 1500, just keep adding those bytes on and the commas, so that we're building out this huge string of bytes separated by commas. And as soon as that length hits above 1500, it's time to send it out. So that's when you'll see. So if it's less than 1500, we're just doing that. Otherwise, time to connect and send the packet out. So the target URL never changes throughout this. It's going to be the same file name with the same timestamp. So we're going to keep that the way it is, and then we're going to connect to it and then do our post of the payload and send it out. That's it. So at the PHP side, it's going to catch this and store that as an image. It's going to store that in that file. And you might be wondering, well, what do you do for the next packet? Well, we're going to go ahead and send the same target URL. So it's going to open that same file and append to it. So it's going to add that, all of those bytes we've added on, all of that entire string of bytes separated by commas, it's just going to add to that same file we already have on the server. Okay, so we go through that and it spits back the total number of bytes that are in that file. So when we look at the PHP code, that'll make more sense. And then we're done, http.end, and then we set it up again, payload equal to the value. So the value is the tag we're looking for on the PHP side, so that we know, you know, we want that, it's value equal, and that's what we actually use for all of the data we're appending to that file. And because we jumped into this with already reading in a byte, we got to start it up. So right here, value equal, and then we throw what we already read on in there with a comma, and then we're done. And I flash the LED every time we're doing this too, so that we can see it actually working. Okay, so we reset the payload packet and then loop through this whole thing until we deplete the buffer. Now, the thing that's going to happen though is eventually we're going to hit the end of the packet, and the end of the packet is going to be FFD9. So as soon as we see that, just break out of that. So we hit the end of the packet, or the end of the buffer. I keep saying packet, but we hit the end of the buffer. So we got to break out of this, and that's what we do. And by the way, I always put these yields in when dealing with the ESP8266 so that it can handle the housekeeping needed by the Wi-Fi stack and all of that. So, okay, so we break out, we found the end of the buffer, but the problem is that we're probably in the middle of building up a payload when we found the end of the buffer. So we've got one last thing here to just send out whatever we had laying around. So obviously if the payload.length is greater than 1, we've got something left in the payload, and we always would have something left over. So we do the same exact thing, begin at the target URL, do the post with the payload, and then it'll spit back and tell us what the total file size is. And I was actually at one point keeping track of all of the bytes and comparing that to what the cloud was sending back and just making sure everything was working. And then it is done, finally, okay? Then the last thing we got to do is let go of the chip select pin. And this is important because if you're going to continue to hold the wake button through this, it will never be able to detect it because you're still yanking on the chip select pin in this code, which is shared with that external wake pin. So you got to let go of it, configure it as an input to allow the button, the wake button, to be read in by the ESP8266. Wow, that was a lot of code to go through. So now if we jump back here, upload picture is done. We have the image is already in the cloud. So now what we do is actually send the link to the image to Slack. And that's what this does. So it sends the battery is equal to this voltage, and then we have this, okay, which is we're doing a whole sprint to build this out, and we have the battery buffer going right there, and then we have the file URL going right here, which is going to have the / images, because we have a folder in the server called images, / the file name, which goes right there. Okay, so it builds the whole thing out for us, and then in Slack, when you go to it, you'll see the image. And there's a lovely picture of me. So you see, what's nice about Slack is that it sees this link here and automatically loads the image for you. And if I click this, well, we can actually go to it in the cloud. So there it is, the actual link to where that is. So now we can actually get into the PHP code and how I set this up on the server. Okay, so I'm hosting my website through HostMonster, but they're all the same. As long as you can get to a file manager from the cPanel, you should be totally fine. So this is where I'm actually storing the images. And in here, this is the one I created just for this video, just as an example. You see we have the PHP code that we're going to review here in a few minutes. The images folder, just create new folder, call it images, just like that. And for good measure, throw in an index.html file. So just new file and just call it that. And now when you go to this folder, nothing shows up in your browser. Do the same thing in the images folder as well, so that if somebody were to navigate just to images, they don't see all of your pictures there. Again, this is not HTTPS, so it's not going to be that secure, but it's kind of a cool, fun DIY project. Okay, so now we have that created. We can go to the PHP code. Okay, here's the code. You can download this from the wiki, and this is what is called. This is called, from micro.php, and this, the Arduino passes this as part of the URL, calls this up, and in there you'll see data equal to, and that's the file name. So, you might remember that. When you look at this code side by side with the Arduino code, it all kind of starts making sense. So right here, this little loop here that it's looping through is actually looking for this key data, and that again is the file name that it's going to go and open. So if it doesn't exist already in the images folder, it's going to create it. But if it does exist, it's just going to append the data received here to that file. And again, we're posting the data in an HTTP post, and that is caught right here as a value. And we're just, my variable naming in this is just terrible. But we're storing the entire data string from that post and calling it data. And you might recall that each one of the bytes sent in from the buffer out of the camera was separated by a comma. So at the PHP side now, we're going to separate it out, and we do that doing an explode function on it. And we've got our separator there, the comma, and it's going to separate this now into a massive array called txt. So I think I pulled this out of some example and just left the variable name alone. But so now txt is a big array with individual bytes for each element, okay? And this was really, really hard to get right. I had to go back and forth and try a million things. And I'm sure there's like some super easy way of doing this, or, maybe even just a way to just upload the entire image all at once. But I couldn't figure that out, and again, this was like a weekend hackathon to get this all working, so this is what I came up with. Okay, so now we have that huge array. We want to grab the count of it, and then what it does is set up a new string here, data to be written, and then we've got a for loop right here that loops through the entire txt array and basically just add it to the new string. So now it's taking the array and creating a huge string. So it's going to be like we're coming in as data. It might have been 255, 255, 255. Data to be written is going to be a big string, just 255, 255, 255. Okay, so that's what it's doing here. And if you actually worked through this and tried to do it without the commas or whatever, you'll experience some of those issues I ran into about, I don't know, 2 months ago when I was actually working on this. But it took a long time to get all this working. Okay, so now we have the big string of bytes, and then file to write is going to be in the images folder / and then the dot is an append to that, and the file title we got in that came in up here as part of the URL, and that's the file. And again, if it's there, we're going to open it. If it's not, it's going to create it. Okay, and that's what is done right here. Fopen file to write. And we go ahead and just write that data right into it. Close the file out and then echo the file size of the file. So you'll see that in the when you actually connect this to a USB to serial converter during the upload process from the ESP8266, you'll see the image file size increase as it goes through the upload. Okay, so that's all there is to it. And if you go here, just throw that, let me go up one level. So just throw that from micro.php in the directory you created here. Again, this is the URL you're going to put in the Wi-Fi manager. Don't forget that / in there, and create the images folder, and then you're all set. So that is pretty much the entire project there. So I might make some follow-up videos if there's any questions, maybe a little bit more of a deep dive into different areas, but that's the whole thing. Thanks for watching.